Okay. Presenter view. Okay, great. So I want to put that there, here. Okay. All right. New share. I'm just going to do this one. Okay, so now you can only see my browser, correct? You can't see anything else?
Yeah, we can see a browser, yes.
Okay. Can you see the little box that has my speaker notes on it at all, or is it? No, right?
Partially.
So I think you can't, which is great, because that's where all my notes are, and I'm just going to talk as if I'm speaking from there.
Okay.
Okay, so let's pull this all here. And then okay, so I am ready whenever you are. Let me know when we should start.
Yeah, I think we should. All right, let's do it.
Okay, let's get it going. Let me pull my notes. And okay, hi. My name is Chris. I am here to teach a little bit about ApeWorks and how bridging Web 2 to Web 3 with Python is very easy.
Culotte.
Yes, we're good. Okay, excellent. Okay, cool. So let's see. Everyone today is using Web 2, and which is the modern version of the internet. And one of the most common languages to code in is Python. So today I wish to show you how to understand Web 3, what it is, through the lens of a Web 2 Python user. So just a little bit overview as to what we're doing. I want to talk a little bit about me. What is Web 3 and its principles? The Twitter concept conversion to Web 3, and how to use Python Web 3 native tools like the framework and plugins, how to get started, and where can you learn all of this to just get started into Web 3 space. Okay, so my name is Chris. I work at ApeWorks. I am half engineer, half degen. I always fly chaotic, meaning that every time I fly, there happens
Why I'm
something
actually
always...
here, bro?
Say it again. Okay. I just wanted, because every time I fly, there's always something going wrong with the whole trip. And I always find that absolutely hilarious. So I'm based in Los Angeles. And whenever I make ask a lot of dumb questions within my company, I get a lot of good feedback, and I try to turn that feedback into DIY, like instructional videos on how to do specific things based in Python. So fun fact, all of these photos have some sort of story behind it. So if you have questions, feel free to ask me these questions about these photos, because I'm always happy to share the story behind them. Okay, so what are the Web3 principles? So to understand that, we are going to take some vocabulary from the Ethereum website and just talk a little bit about it. So Web3 is a decentralized web space where there are large swaths of internet controlled and owned by centralized entities. Ownership gets distributed among its builders and users. So we're trying to pull away from the fact that a lot of the data is hosted into central servers, where we're trying to make it decentralize it. So Web3 should be permissionless. Everyone has equal access to participating Web3, and no one gets excluded. It's a large space for anyone and everyone to communicate to. It doesn't matter who you are, you should have the same amount of access as everyone else. Web3 has native payments, meaning that there is a version called, cryptocurrency, like you have like Ethereum or Bitcoin, for sending and spending money online instead of relying on outdated infrastructure of banks and payment processors. And Web3 should be also trustless. So you can be yourself or some sort of entity that's that is there, and you can act as your own and act as representing someone, and it doesn't matter who you are as long as you have the same capabilities as everyone else. But in the terms of vocabulary, it operates using incentives, economic mechanisms, instead of relying on trusted third parties. You have direct ownership of your name. Everything you can do can be signed through an address that is 64 characters, and it can be authenticated with your signature, which is that address. And once you sign everything that you sign can be, or anyone else that signs anything that they do, can be verifiable. They can check to make sure that it is you, and you do all these things based off of who you are. And when you check something on a digital ledger, like a blockchain, for example, everything that is on there can only be added, not mutated and viewed. So it's public. You can add to append to it what they write, and it's open for everyone.
We're still waiting for Chris, but guys, can you hear me well from on our side?
Yes, that's perfect.
Okay. Yeah, it's just internet connection with Chris. So give him a couple of minutes to figure this out, and hopefully it's going to be all right.
Hi, I think we're okay now. Yes. Okay, am I back? Just wanted to make sure. Okay, we're all good. Okay, excellent. Thank you so much. Sorry about that. Let me pull my notes one more time, and we're back to where we're back to this. Okay, so sorry about that. So Twitter is an online social networking site where people can communicate via direct messages, tweets, and other engagement tools, as we know and love, correct? So as we know, Twitter is hosted on a centralized server where a lot of the heavy lifting is done at the server level. But with the inversion of Web3, we can invert the paradigm where the client does all the heavy lifting instead. And we want to do that because all we want to do, the servers to do, is have a consensus of information. And when everyone can agree on that data, we can fetch content and display it, knowing that the original content is accurate. So for example, or not for example, to explain the client server model, the client server is a distributed application structure where partitioned task or workload between providers of a resource or service called servers, and there are servers like clients, so like apps like your phone or a website will access this information and display it the way it's given. The inversion is on the emphasis on the client, not the server. The server, the client does heavy lifting, the server does the consensus, and whenever we can agree, we could do all this as we know. And so the way we want to actually talk a little bit more about that, trusting a source of information has value itself. You could build meaningful relationships with the data, like direct messaging and tweets. For example, we're going to talk about all of the stuff that you do. Let's pull it right back to here. Okay, so for example, my username on Twitter is NinjaGod1251. I have that username, and everything I do is signed by a 64-character hex string address. So when you look at the history of data that history of transaction interactions that I have done, you can see that NinjaGod has done this, and you can see that I sign every transaction, every tweet I've done, every message that I do, it's me. And when you go and try to look at the history of what this specific address has done or this username has done, you can see that every time he's done something, it is my address and I have signed it. So you could trust that it is coming from me. Web3 is a serverless architecture where it serves as the coordination layer between the client and server. The 64-character hex string address is generated by various rules from the Ethereum yellow paper. You can read a little bit more about that, but just know that this 64-character hex string is me and it's uniquely mine. These direct messaging channels can be encrypted with your hex string with an asynchronous lock, and cryptograph is based in Web3, and it's a very fundamental part of the principles. For example, PayPal is a third-party way to send money, but in Web3, my money is my own. So when I send it to you, I sign it saying that it is me from you, and we use small blocks of code to send money that it is from me. So you could skip a third party, skip the transaction fee, and just send it directly. So that is some really cool examples about how we can convert the Twitter or PayPal version into Web3 aspect. Okay. All right. And so now let's talk about some Python implementation to Web3. How can we use our Pythonic tools in a way that we can use it into the Web3 space? So a really cool way to get started is our framework and plugins. So ApeWorks is an open source Python-based framework you could build small blocks of code called smart contracts on. In Web3, in order to interact with a digital ledger called a blockchain, there are things called smart contracts. And the digital ledger is a way for us to log important key transactions on chain so anyone can view your interaction. So if in the Twitter example, if you want to log a tweet, you put this tweet out there, anyone can see it, anyone can verify that it's you, and it's secure. And so with that being said, there are ways to incorporate appending data to a digital ledger, and our Ape framework is a really great way to get started. And the way it works is like, in Python, there are a lot of plugins to interact with it, but there are some specific native Python plugins for you to get started on interacting with a smart blockchain and smart contract on a blockchain. And so, for example, there are ways to write your contracts. Viper is the most Pythonic language. There are some really cool utility to convert your name into a hex address. Web3 is a very core.
Recording in progress.
Okay. And then there are a lot of network providers to access multiple different blockchains that you can store your information on. So, for example, Web3 is a tool that we use internally, and we in Ape, and it helps us send transactions, interact with smart contracts, and reading block data, and a variety of other use cases. For example, not for example, and so we know that's how we use it. And to show that you can use Python in it, this is the Pythonic language Viper to write your information. So this is just one small block code in here. And we're just going to try and pull it through. Okay, so Framework is the premier Python-based framework for smart contract developments. It's open source. It has a modular plugin for you to use or make. Ape Console is an IPythonic console for contract interaction or your code interaction. And you can also live test your interactions and figure out the way, make sure that your work is used as intended. And if you wanted to learn all about this, we could talk a little bit about ETHMiami right after this. So for example, this is our Ape console. And one of the cool things that when we switch from proof of work to proof of stake,
Shut the fuck up, bro.
we can see that the block number changes down from the base fee, drops down significantly. That's why we're using Ape console to get here.
No, stop it right now.
Okay. All right. And so the next thing we're going to talk about is smart contracts. You can write your smart contracts in Solidity or Viper. And it makes for a way to write. So this is actually our project hierarchy, right? And so, let's see if we can figure that out. Give me 1 second. Yeah, 1 second while we try and figure out some work behind this.
Yo, bro, you want to kick me? No way, bro. No way.
Give us 1 second while we try and figure this out. Can you give me admin access? Because I can do that right now. Okay, he is gone. I think we're okay. I want to try that one more time. Excellent. Okay. If you really want, you can also change the password, however you guys want to do it. Anyways, let's just get right back into it. I'm just going to leave my camera off. We're just going to pull through this. So smart contracts are a way for you to interact with the blockchain, and you can write really smart Pythonic contracts here in our framework. And scripts are a way for you to interact with this contract as you see intended. So say this contract gives you a way to make NFTs, non-fungible tokens, to show that it is you. You can mint tokens, mint NFTs by using a script to assign people with usernames and addresses on Twitter an NFT or a picture assigned to it. And so you can deploy it on there, you can ingest data, you can make Oracle scripts to grab data from outside of Twitter and bring in reliable information. So let's try and figure out how to do some academic work on this. So if we go to our website, academy.apeworks.io, this is how you can get started with a Pythonic tools to know and love. So for example, testing on Python is exactly the same on in Web3. So if we use our Pythonic framework, Academy or ApeWorks, we can do it right here. So we can get started by figuring out how to get it all working. So just like we're going to do a virtual environment. We're going to activate and deactivate to make sure that it works. We're going to set it up as well, and then compile a contract using ERC20 tokens or 721, and we're going to try and pull through to the template here. So we're going to go to, let's just do a quick NFT. And so when we get to this 721 NFT, we're going to try and pull through to do it here. So this is our website, you can watch the video on how we do this. And then there's written content to show you how it gets done. So I'm going to pull up everything first. So the first thing that you need to know that when you say get started, it requires that you either be in Linux or Mac OS because it runs on Linux operating system. So let's just make a demo folder, DD demo. We're going to make an environment, which we've already done. Let's just call it, we already have one. So I'm just going to activate it. So activate ape works. I think it's just called ape. Yeah, just ape. We're going to pip install update first and then install our ETH ape. We're going to do pip install ETH-ape. Actually, we're going to do the first one, pip-u. Cool, that's good. We're going to do pip install ETH-ape. It should be already installed, but we're going to update just in case. Okay, and to make sure that it works, we're going to just type in ape. Perfect, it does run as intended. Okay, great. So now we're going to go into our 721 token and get it to run. So the goal of this tutorial is to teach you the foundation of a compliant NFT smart contract so you can build your own. ERC 721 is a standard for NFT non-fungible tokens. For every token that is collected and described in the smart contract is unique. The tokens represented are an integer called token ID, which represents an individual token. This token ID can be referenced for unique metadata for each token via a link to an external location, which is an immutable storage called like a blockchain. The proof of ownership can be found and performed checking the signature, which is you, from the account that is holding the token. So this contract is responsible, this block of code is responsible for keeping track in the creation of the token on a blockchain, for example, Ethereum. So what we just did was just activated the source, and we're going to go straight into installing the template. So we do ape plugins list, all to see all the plugins that we have installed. And so we're obviously going to need the templates one in there. We already have the Viper one that we need. So let's do ape plugins install. The template is in the behind the scenes, it is cookie cutter. So it just takes this ape template, ERC20 721 project, and run through the template. So if I were to go to the Academy, it's ERC 721 token template. And this is the code that we're going to try and use. And so we do, now if we look at it again, we do ape plugins list again, we should see that the template should be installed. It is right here. So we do ape.
Chris, we can't see what you're showing on the terminal.
Thank you. I am going to switch to the full screen, new share, and do the whole entire screen. Perfect. Sorry. Okay, so now we're back to it. We do the plugins list -- all to see that we have all of the things that are required. So the template is installed, the Viper compiler is installed, and we're going to run through making this template. And so the next thing that we have to do is do this template. Do ape template, and we should just go here if we wanted to, and just copy the code here. Do ape template. There you go. See if I can do this. There you go. It's a little bit bigger so we can see a little bit more now. Asking if we want to make it re-download. Yes, I would say do that once in a while just to make sure that it is the most up-to-date version of the template. Just call it do ape demo. Token name, you're going to just call it ape. And the APS is fine. If you like the default, you could just press enter, 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 enter to keep the default information. All that is fine. Great. So now that we've made it, we can go into the project itself and we can go to CD ape demo ls, and we see that our project hierarchy is exactly the same what we described earlier. We have the contracts folder, the script folder, and the test folder. And then what's specific about the framework is that we have a config.yaml that does everything. So we can see that the NFT smart contract is here. The script folder has the deployment here and the test that tests all of your methods is here. So, you check the total supply, you want to check a transfer of your minting of the token, making sure that if the signer is trying to transfer and that is not you, we're going to make sure that it is correct. And so this is how we do like stress testing and making sure validation of owners. Okay, so now that we've made it, we're going to go into the terminal again, making sure that we're on the same correct path folder, pwd ls, we're here correctly. And just to follow along to make sure that it is correct, we did reading the content, the interface. This talks about the different specific methods in this project to talk about why it's there and how it's important. You can read a little bit more about it, but I'm just going to try and get you to get there to deploy. And so these are all of the information about the whole thing. And so now that we've created the contract, we're going to try and test the contract. And testing the contract is actually really easy. All you have to do, since it's already made, you do ape test. And it runs through that entire folder. Right here, it runs through this entire folder of tests right here. And so it checks everything as intended to make sure that it runs properly. And now that we know that it runs properly, we're going to deploy the contract on a blockchain and try and get it to run as intended. So we review tutorial. This one is done with ERC20 token, this tutorial is done with ERC20, not the 721, but deploying the contract is the same in the same framework. Okay, so we're going to go to this. So specifying a network, we're going to do ape console. Okay, excellent. So we're going to clear. We're going to do SP. We're going to do ape console. And if we don't specify, it's just going to go through the default network, which is your local test net, which is fine. So we're going to load accounts from a test account. So with ape was actually really cool is that we have a default test account. And also if I'm going to go over time, please let me know. I'm just trying to finish up. And I think we're almost done. So we go into here. We go into test account. Test accounts. So here we go. Test accounts. And we can see that accounts dot test is here. So test accounts come preloaded with some fake test money that you can deploy, because every time you try and append data to the blockchain, it costs some sort of fee to do it. And so we don't want you to use real money for this. You can just use the fake test money that we have loaded into our framework. So we do, like they said here, dev accounts.load. And the dev is an account that we have with fake testnet money. But if you want to just load from the framework, we're going to use the test account preloaded in our framework. So we're going to go to here. we're going to do dev equals counts this right here. Copy. Should we just do that? So now we can just do dev dot check all these different things, but for example, we're going to do balance. Sorry, not balance. There you go. It has a lot of GUI in it, and we can run it as we need it. And so the next thing we're going to do is try and deploy. So we're going to take a look at dev.deploy.project.token. And the token is just the contract name itself. So if we were to look at the contract name is NFT. So for our sake, it's going to be contract equals dev.deploy project.nft. And we have successfully deployed the project. The smart contract is now living on the blockchain, and you can interact with the contract as any way you see fit. So if we just do contract, we can see that the address of that smart contract is here. So if we do contract.tab, all of these methods are defined. All the specific special methods that you have defined are here. So for example, if we look at this, is minter total supply. If we're looking at symbol, we can return the name. It's all here. So we do contract.name, and we try and see it. What we defined earlier, our contract is ape. So we do contract.symbol. You see it all here. And so we wanted to contract.mint mint an NFT to a specific person. We can look at the mint function and see that the argument is we need to send the NFT to a specific address, and you'll return back a unique number. And so you can see it all right here. So we just do ourselves, we can just do dev equals, and then we need to sign it with the sender equal dev. And I believe that should be okay. Nope, we're looking for a string. Okay, we need to do, we need to just do that, check out what dev address is, and we can just run it by that. So it's just that. Okay, we do one more. It's looking for an address, not a string. Okay. Address encoder, address, minter, receive, token ID, content of ID. And actually, we can just look at the deployment test script here to figure it out. We do NFT, we do all of the transferring. Where's the mint function? Test mint right here. So we check the balance of, we see the receiver address. Perfect. Okay, and we're going to just try and do dev.address. Excellent. So we can maybe just do that instead. Is the same here. Yeah, there you go, dev. Excellent. Now that we have minted the address, we can do contract, not mint, but check the total supply. We have minted one token and one NFT, and that is yours. So this whole template works. We were able to deploy within like 5-10 minutes. And if we want to learn why this information is powerful, you can really just come check us out on our Discord, on our come say hello, and we'll help you build your own Web3 application. So this is us. We're going to be the next time we're going to meet in. If you want to see us in real life, we're going to be in ETH Denver in the first week of March. If you want to learn how to do all these ape challenges, we're more than happy to walk you through this whole thing. So come say hello to our Discord, and that's all we have for today. So thank you so much. And this is the QR to the slides if you want to check it out. So thank you so much for having me.
Okay, Chris, yeah, thanks a lot for your presentation. Maybe we'll just, do we have any questions to Chris? Anybody wants
Yeah, I'm
to
happy
ask
to
questions?
answer some. Yeah.
Yes, no?
You have to be here. Some of the scripts are written behind some.
Yeah, 1 second. 1 second. Let me just
It's
get
a
the
little
mic.
hard to hear.
Yeah,
If
1
you
second.
would-
Let me just get the mic. 1 second. Yeah. Can you
Yeah, of
please-
course.
In
If
this
you have any
case,
questions,
some of
you
the
can also
scripts were
post it
written
in.
in Python, some in Solidity. Or can you
Yes.
have them all written in Python?
Yes, you can either write it in Solidity or Viper, which is the Pythonic language, and our framework will accept both. You just have to choose the right compiler to the right language. And we have a really powerful proof of concept where you can write multiple different contracts in multiple different languages, and the compiler will pick the right compiler for the right contract to compile to make sure it works as intended. And you can check that out with the ERC 4626 Vault contract, which is, if you look here, it is built with Solidity and in the Pythonic Viper. So yeah, so good question. Thank you.
Anybody else? All right, Chris, thanks a lot for your presentation and really appreciate it. Thank you. Thank you for joining. us.
Yes, so sorry about the little mishaps, but hopefully I was able to be clear about what we can do with Python, and hopefully to get you guys started in this space, because it's been really exciting and been really fun to learn about this whole process. So happy to teach you as much as I know. So thank you so much for having me.
All right. Everyone, have a good one. Thank you.
Thank you.